So today's video, we're working more on how to use the area model for polynomial multiplication. And we already know how to use the area mats for integer multiplication. We already know how to use the area mats for integer multiplication. The only difference with polynomials is, one, the shapes we're using. The shapes we are using are different. So you might use, in integer multiplication, we're only ever dealing with the small integer squares. But now we have to deal with x rectangles and x squared big squares. And the other thing that's different is that sometimes a factor can have a positive part and a negative part. So sometimes a factor can have a positive part and a negative part. Before, when we only had integers, it was either a negative integer or a positive integer. But now we can have something that might have a positive part and a negative part to it. So we're going to do two examples. In the problem, -3 times the quantity of x plus 1, one factor is -3, and the other factor is x plus 1. So we can model this with a rectangle of length -3. Actually not with a rectangle. I shouldn't have said rectangle. Cross that out in your paper. We can model this with integer squares of length -3, which we model vertically in the factor check. We can model the width of x plus 1 horizontally in the factor check. Okay, so I'm going to move this. We'll finish these notes in a second, but I'm going to move this and show how we can do this, okay? So remember, we're doing -3 times x plus 1. We want to be able to model horizontally. We want to be able to model -3 vertically. So -3 vertically would be right here, right? And we want to be able to model x plus 1 horizontally. So that's all positive, so that would be right in here. Okay, so I'm going to show this part of the quadrant. Vertically, we're going to model -3. We have -3 integer squares. And then horizontally, we have x plus 1. So see, the shapes are different. The method we're using isn't. We still put one factor here for the length and one factor here for the width, but now the shapes are different. Now we don't just have integers, we have different shapes. So we have x plus 1 here. So that's how we model the factors. Now we have to decide what shapes will fill out the area. What shapes will fill out the area? Okay, so let's look at this. What shapes are going to fill this area out? What shape is this long and this wide? Well, a rectangle would be this long and this wide, and we know it's negative, so we're going to need a negative rectangle right there. And same thing, we need another shape that's this long and this wide. That's another negative rectangle. And we need another one that's x long and 1 wide. And then here, what shape is going to be 1 long and 1 wide, 1 long? That's going to be these little integers right here. And 1 and 1, so it's going to be another little integer. And 1 and 1, so it's going to be another integer. So we figured out what shapes are going to fill out that rectangle. In this case, we have 3 rectangles and 3 unit squares, right? We have 3 rectangles and 3 unit squares. So the product as an algebraic expression is negative 3x plus negative 3. That's what we see right here. Negative 3x plus negative 3. Remember, we only count the area mat, not the factor check. Okay, so take a minute to go ahead and draw this in to your own, where you have the negative 3x's and the negative 3's. Take a minute to draw that in, or fill it in after this is done. I'm moving on to this problem. In the problem 2x times the quantity of negative 3x plus 2, we model the length of 2x, right? That's the first factor, 2x vertically in the factor check. Then we model the width of negative 3 plus 2, negative 3x plus 2, horizontally. We put the rectangles on the negative side. So this is the one situation we were talking about up here, where we said sometimes you have a negative and a positive part. So we put the rectangles on the negative side. And we put the unit squares on the positive side of the factor check. So that's really the only 2 differences, is the shape and then what we put in. So I'm going to show you how to practice that, right? We're going to need 2x vertically, so that's going to be right in here. And then we're going to need to put negative 3x's over here and positive 2 squares over here. So that's basically this part of the mat. So we said we're going to model 2x vertically right there. And then we need to model negative 3x plus 2 horizontally. The negatives go on this side. And the positive part goes on this side. So the strange thing here is then we need to fill in area mats on both sides. Okay? So when we fill out the area, what are we going to need? We're going to need to fill out the area on both sides. We're going to need something that fits x long and x wide. And that is this big x squared shape, right? And again, it's negative, so we use a negative one. So x long, x wide, another one here. That'll fill out the area. X long, x wide, another negative x squared shape. X long, x wide. So all here, the big squares fill this part out to fill out this rectangle. And then over on this side, we need something that's x long but 1 wide. And it needs to be positive. So here, that's just the rectangle shape, the x rectangle shape, right? So we fill those in. So remember, when we're finally counting the product, we don't care about what's here on the factors. In fact, once you fill it out, if you want to move the factors, you can. The product is what's left on the area mat. So what's left on the area mat, we needed 6 large squares. We need 6 large squares and 4 rectangles, right? And 4 rectangles. So the product as an algebraic expression is 6x squared, because those are all x squared, negative 6x squared, because they were negatives, right? Negative 6x squared, and positive 4x, plus positive 4x. So that's your final algebraic expression. So on your homework, make sure you do the models, but also make sure you write your algebraic expressions.